Look at the exterior of any premium smartwatch today. It is a completely unbroken expanse of metal and glass. There are no screws, no rivets, and zero visible hardware holding the face to the casing. You see the same seamless exterior on modern city transit buses, the chassis of high-end laptops, and smooth kitchen appliances. For centuries, manufacturing relied on brute force. To attach two pieces of material, you physically drove a piece of metal through them. To achieve these specific, hardware-free aesthetics, manufacturers are increasingly using bonding techniques that don't require the physical clearance or material thickness that a traditional screw demands. A mechanical fastener presents an immediate engineering paradox. To secure two solid materials together, your very first step is to drill a hole and permanently weaken them. This heat map shows exactly what happens inside a joint. A rivet or a screw forces the entire physical load of the structure to converge on a single microscopic point of friction. That intense, localized pressure point is often where structural failures begin. The tension causes the surrounding material to distort, craze, and eventually split apart. Because of that focused stress, manufacturers often have to use thicker substrates. If you try to drill a hole into the ultra-thin metals or fragile glass required for modern electronics, the material can shatter under the concentrated load. Every screw requires a surrounding reinforced area to anchor it. For engineers trying to shave millimeters off a device, those individual anchor points become a significant constraint on how thin a product can actually be. The alternative to the drilled hole is the continuous bond line created by structural adhesives. Instead of anchoring at a single point, an epoxy or adhesive can be applied in a continuous path, tracing the entire internal perimeter of a smartphone casing. This heat map shows the structural load spreading across the entire surface where the materials meet. Distributing stress like this allows the joint to handle tension as a single unit, letting engineers safely use thin glass without the risk of cracking. You can see the effect of this distribution when applying a light-activated formula, like 3M's 5001 clear epoxy, to a glass substrate. It cures with minimal warping, while the side using traditional epoxy shows the extreme curve caused by localized cure stress. Chemical bonding leaves the original components intact, preserving the structural integrity of the materials being joined. Structural failure isn't always caused by physical stress. Every hole drilled into a chassis is an open door for water, dirt, and rust. A continuous adhesive bond creates an environmental seal. It joins the materials while blocking outside elements from reaching internal components. This sealing effect also helps prevent a manufacturing hazard known as galvanic corrosion. Galvanic corrosion is a chemical reaction that triggers the moment two dissimilar metals, like aluminum and steel, make physical contact, causing rapid degradation at the joint. Because structural adhesives sit between the two substrates, they act as a physical and electrical insulator. The opposing metals never touch, halting the chemical reaction. A single application of epoxy can solve environmental and chemical vulnerabilities that a steel bolt might otherwise create. Engineered solid tapes, like the 3M VHB line, are a core part of this structural toolkit. These tapes operate on a property called viscoelasticity, which allows them to function as structural replacements for rivets. Viscoelastic materials act as microscopic shock absorbers. They sit between two rigid surfaces, flexing to accommodate movement. This allows the joint to absorb dynamic loads, dampening vibrations that loosen screws. It also manages thermal expansion mismatch, stretching when glass and steel expand at different rates. The joint becomes a dynamic component of the physical assembly, rather than a static, rigid anchor. Modern manufacturing is increasingly moving away from mechanical fasteners in favor of advanced chemical bonding. Removing physical hardware reduces bulk, saves weight, and eliminates the manufacturing noise associated with drilling and traditional assembly. Engineers can now combine materials that were previously difficult to join, such as attaching lightweight composites directly to heavy metals. This hidden architecture is a major reason modern technology looks sleek, allowing aerodynamic lines to flow over a perfectly unbroken exterior. Modern structural strength isn't always defined by heavy bolts. Often, it's the result of highly engineered, microscopic bonds that remain completely invisible.
Contact Sanligao, one-stop chemical provider for your need.